that comes in. Okay. Identities, here we go. An identity. You are ready for this. Is an equation that's true. For all values of a variable. My example is 2x plus 5x equals 7x. So you know what? No matter what I put in for x, that is going to be true. Yes.
What if 1 equals 1? There's no variables involved.
That's true, but that's not an identity. That wouldn't be an identity. 1 does in fact equal 1, okay, but that wouldn't be an identity because there's no variables for it, okay? The idea of these identities, it's going to be... Can we refocus here, please? That would not technically be considered an identity. You have to be able to set values. So here we go. In order to solve these, we use all our math skills that we've learned. Examples of these are going to be adding rationals. We have factoring. We have, what else do we have? That's what it is.
Distributing.
Yeah, distributing, I guess. Plus 2 new skills. And today we're going to talk about the 2 new skills that you're going to learn and you're going to use. If you get stuck on an identity that we're going to do here, and again, Leon was already worried about this before he starts, don't be worried, you can do it. Okay, use one of the 2 new skills. Okay.
We're going to go hug the school again.
Did Olivia change? That's the question.
Identity prices.
Chase on has never bothered me at all. How can I help you? Yes.
Yeah. No, tell him I can't. I have to learn this. She says no. Please, like I would, but I actually want to learn this. I'm just scared to do that. I don't want to risk my life going back there. Counting them. I guess I was doing
I can get home.
He's probably gonna call again, but
Something hockey related. Oh, hockey season's over.
no, it's
Sort of like that. Yeah. But the other thing I should probably put on here for this is, hold on a sec here, is you have to use each side exclusively. So when I joke about identities when I do them, I say there's an imaginary brick wall down your equation. Okay, so you cannot like multiply both sides, you know what I mean, or like to divide by 3 to solve for x, like to do one thing to the one and the opposite operation. You can't do that. There's an imaginary brick wall down the middle. You're going to use algebra on both sides to solve them, and then finish off the answer. Let's talk about our 2 new skills right here. Okay, the first one is going to be the Pythagorean identity. And I have a joke, also the director doesn't come in when I tell this joke. If I'm mid-joke.
just say yay now.
I have one offensive joke to start off with. Here, the Pythagorean identity. We're going to start with the unit circle. Okay, so this is what we, can we go ahead, please? This is what we started with yesterday, was that, okay? What I did then was I wrote my triangle sort of like this. Is that looking familiar to what we did earlier in the course today? It should be. All right, where do I stop here now? Grace, I'm going to pick on you. I do not like y and x at all. What can I replace y with? What's y the same as? A little louder, Aaron? Y is going to be sine theta, lovely. All right, Krista, what is x going to be the same as then? Cosine theta. Now this is called the Pythagorean identity. Does someone guess, Brad, what I'm going to do? Oh, so we play along here. What's the Pythagorean? What are we going to probably do? Go ahead. Yes, I am. Okay. So what I'm going to do is I'm going to say sine theta squared plus cos theta squared equals 1 squared. Now, one sec here. Now the reason this is a powerful tool, what I've done is I've related sine and cos together, which is miraculous, okay, right? It's very cool. Now I'm not going to write a sine theta squared, and for everyone fading out here, I'm actually going to rewrite this as sine squared theta. And there's a question someone was showing me in the textbook a few nights ago that they were writing it like that, right? They had like tan squared theta or something like that. So all that means is that sine squared theta means sine theta times sine theta. This is the Pythagorean identity. I'm going to pause the video and hopefully nobody comes by. Yes? Yeah. So if you were to check that, if you don't believe me, try it out. I'm going to say sine 40, if you do this in your calculator, guarantee you're going to get 1. Always. Like you're so believing you don't even punch in your calculator. That's great. You're guaranteed to get 1. Okay? Did it not work? Did it work? What?
It works.
It does work. Who's doubting me? Oh my goodness. Where's calculator? So if I type in, hold on a second. Wait, goodness, now I'm worried here. If I'm going to type in bracket, 46 sine, bracket and square that. I'm going to add bracket, 46 cos, bracket squared, equals.
Brackets. Oh,
Okay, it does actually work. Okay? Now, I don't.
Why?
Why? Why do you ask? This is why right here. This is why right here. Okay, now, we can get, this is called the Pythagorean identity. If you're saying to yourself you don't think you can remember this, I'm going to tell you don't, it'll make you remember it.
How's tan falling?
It will in a sec. 10 will happen in a minute, okay? We can get, I'm going to tell a joke here that's off to remember this, okay? So, here's the joke. This show is so old, my wife tells me I need new material. Sorry, my friend, I can't talk about it. There used to be a TV show on television called Beauty and the Geek. Okay, it's like a really old show. So what happened was they would get gentlemen that were highly intelligent but with low social skills. Okay, those would be the geeks. So these would be people that in a costume like this, like wouldn't be able to talk to anybody or anything like this. And they put them in awkward situations, like they'd have to go into a bar full of beautiful women and get like 25 phone numbers, right? The difficult thing. And with them, and in the same house, they put them beauties. So these would be, I'm going to say this nicely, women with strong social attributes, but not very intelligent. Okay, I said not be offensive, but that's what the show was. Okay? So it was a highly offensive show. I don't know why I was watching it. Now, the joke comes from this. They had one of the gentlemen on the show where they said, like to introduce everybody, they said, so what's your best pickup line at a bar? They go, oh, I thought it. Hey baby, I'm sine squared theta, and you're cos squared theta. Together let's do 1.
Wow. That's a good
It
pickup
worked for me
line.
and my wife, so not a joke. Anyway, so that's my offensive joke for the day. Now, where this is useful to us, well, you'll remember that too, hopefully now. Yes. Oh.
Yeah, so it's like a pineapple, like a little bit of the brown part, and then
Okay, where this go, we could go in here, please. Where this is useful for us in our course here. This can help me get a value for sine and cos. Can somebody tell me what sine squared theta is equal to, please? What's sine squared theta going to equal? Go ahead.
1 negative cos squared theta.
Lovely. Hold on, now everyone's taking notes. Can you explain to the class how you got that? Good. Okay, so the sine squared theta stays the same. The 1 stays the same. The cos goes from the left to the right and switches its sign. Okay? That's all that happens. Okay? So now what happens is if you get a sine squared, why? Because what might happen in one of these identities, if you have a sine squared and you want to get rid of it, now you can get rid of it and change the cos. Right? That's just the advantage to it. In the same way, cos squared theta is going to be 1 minus sine squared theta.
So sine is, oh, okay.
Yeah.
So if the 1 was actually a 2, then you have to put a 2 by the sine of the cos.
Right. So it's 2 sine squared theta plus 2 cos squared theta.
So whatever it is, it's like 5.
Yeah. All right. Finally, the next one's going to be the quotient identity.
So the equation can become negative, or 1 minus cos squared theta plus cos squared theta equals 1. Yeah.
All right. So here we go. Next is the quotient identity. Okay. And this one is going to be with tan. Oh boy. Back from our unit circle days, what was tan equal to, please? Slope, good. Can somebody give me some letters, though? Y over x, good. Now here's the neat thing. What's y the same as? What's x the same as?
Is that cos be Joe cos?
Yes. So tan of theta is equal to sine of theta over cos of theta.
It says sine b over tan b equals cos b.
It's actually true.
Wait, what did you say?
Jokes.
So what the thing, okay, so the joke was on the board here, it says sine b over tan b equals cos b. There's a comedian called Bill Cosby who's...
You may have heard of him. He's
You
been kind of
may have
on
heard
the
of-
dumps lately.
Yeah.
Okay, so there you go, there's the quotient identity. So here's the thing, how this is useful to us is, if you see a 1 in an equation, and you don't know what to do with it, change to sine squared theta plus cos squared theta. If you see a sine squared theta and you don't know what to do with it, change to 1 minus cos squared. If you see a cos squared and you don't know what to do with it, change to 1 minus sine squared. And if you see a tan, instantly change to sine over cos. Okay. Here we go. You guys don't know what I'm talking about yet, but you will right now. Here we go.
But does
Example
this
1.
only work for triangles? Or all?
No, it works anytime. Here we go. Example 1. Factor the following. Okay, this is something else that will come up quite often in these questions here that people get mixed up on. So we're just going to deal with factoring. I see sine theta minus sine squared theta. This does in fact factor. Okay. Is there a difference of squares? Doesn't look like it because there's no squares. So how would I factor this then? There's only one way to do it. Square? Yeah, I take it as sine. So I take out a common factor of sine theta. And I'm left with what? What am I left with?
1 negative sine.
1 negative sine theta. Now the reason that works is because sine squared theta is like sine theta times sine theta, right? So it's like x minus x squared. You take out an x, you're left with 1 minus x. One more factoring rule before we get onto our brain busting examples. Here we go, example B. Says sine squared theta minus cos squared theta. All right, so we're going to factor this one. Can someone be brave and let me know how I would factor sine squared theta minus cos squared theta? Factoring. No?
Would it? Well, b squared theta equals.
No, we're not going to worry about solving. We just want to factor this right now. We're going to factor this. The sine squared plus cos squared is equal to 1. Not sine squared minus doesn't work.
Right.
How do we factor this? Go ahead.
Take out the square.
Okay, and do what?
And you're just gonna sine infinity negative cosine squared.
Nope. Okay, this is something squared minus something squared. How do you factor something squared minus something squared? Squares.
Do you have any on so much you just start crying? I have to start thinking me right now.
I never cry ever.
You said you
Except
cried
for
last night.
when Lion King
What about when you're a baby?
and when Raptors were late. When your daughter Raptors were late.
You literally just said you
I
cried
cried
last
when I
night.
heard that.
It was like the proudest
Yeah, you
moment.
said you cried last night. Yeah.
Last night, yeah, I did actually.
He hasn't cried yet today.
I cried in, okay, I have actually, I'll tell you why. Let me stop this. Okay, you guys okay on the factoring there, right? Difference of squares and common factors, those are the two main things left to do. Okay, I'm gonna hit pause the video and then I'll tell you why I cried,
That's that right there.
because that's to factor difference of squares, right? So, okay, I'm gonna hit stop on this video.